Welcome to Mrs. Ward's Math Minute. Today we'll do an introduction to imaginary numbers. First, let's look at the equation x squared plus 1 equals 0. To solve this equation, we would subtract 1 from each side, then take the square root of each side. But we can't take the square root of a negative number, so this equation has no real solutions. To solve these equations with no real solutions, mathematicians defined imaginary numbers. This imaginary unit is labeled as I and is equal to the square root of -1. When we combine this unit I with real numbers, you get imaginary numbers. Let's look at some examples where we would use I. Simplify the square root of -4. From our rules regarding radicals, we know that the square root of -4 is the same as the square root of 4 times the square root of -1. Well, if the square root of 4 is equal to 2, and we just learned that the square root of -1 is equal to I, then we're left with 2 times I, or 2I. A quick note, we always write the real number first, then our imaginary unit. Let's try another example. Simplify the square root of -81. Again, with the rules of radicals, the square root of -81 can be written as the square root of 81 times the square root of -1. So if the square root of 81 is equal to 9, and the square root of -1 is equal to I, we're left with 9I. But Miss Ward, what if it's not a perfect square? Let's take this next example. Simplify the square root of -90. Using the rules of radicals, we can rewrite the square root of -90 as the square root of 90 times the square root of -1. We can simplify the square root of 90 to 3 square root of 10 as it's not a perfect square, and we know that the square root of -1 is equal to I. So we're left with 3 square root of 10 times I. But we will use correct math notation and write it as 3I square root of 10. Well, that's our introduction to imaginary numbers. Tune in to the next episode of Mrs. Ward's Math Minutes to see how imaginary numbers are used to create complex numbers.
Created using Powtoon.